Hi friends, in this video I will discuss about Dirichlet conditions required for the expansion of function as a Fourier series, and will write the Fourier series of a function having points of discontinuity. Any function f of x can be expressed as a Fourier series. Already we have written the Fourier series. I have written the Fourier series for if f of x is defined in some interval of length 2 pi. Means in this case I have taken the value of L as pi. Fourier series a naught by 2 plus summation n varies from 1 to infinity a n cos of nx plus n 1 to infinity bn sin of nx, where a naught, a n and bn are known constants. Provided we can write the Fourier series if these conditions. First condition is fx should be periodic, single valued and finite, means fx should be PSF. You can remember it as PSF, periodic, single valued and finite. Secondly, fx has a finite number of discontinuity in one period. Fx has at the most finite number of maxima and minima. If these three conditions are satisfied, then we can express the function as a Fourier series. These conditions are called Dirichlet conditions. Moreover, the problem of expressing any function as a Fourier series, it depends upon the evaluation of the integral. Our integrals 1 by pi integral fx cos nx dx and 1 by pi fx sin x dx within the limit. I said I have taken the function within the interval of length 2 pi. According as fx is defined for every x in 0 to 2 pi, minus pi to pi, or alpha to alpha plus 2 pi. If our function satisfies all these conditions, then we can express the function as a Fourier series. Secondly, in this I will discuss the case when the function is having a point of discontinuity in the interval. Suppose in the interval alpha to alpha plus 2l, our function fx is defined as, this is defined as fx. How it is defined? It is having some value, say psi of x. Function is equal to some function, say psi of x, when x is varying from alpha to c, and its value is psi 2 in case x is varying from alpha to alpha plus 2l. See here, c is the point of discontinuity. Here in this case, c is the point of discontinuity. Means if I plot the graph of this function, how we can represent the graph of this function? If this point is alpha, this point is alpha plus 2l, and here somewhere c is there, I may plot like this. This is a part of the function fx within the range alpha to c, and when it is varying from c to alpha plus 2l, it is given to be psi of 2x. C is the point of, this point is a point of discontinuity. There is a breakage in the function at the point c. Fine. Now in this case, if I talk about the Fourier series will remain same. That is fx is equal to a naught by 2 plus summation n varies from 1 to infinity an cos of n pi x by l plus summation n varies from 1 to infinity bn sin of n pi x by l. There is a change in the value of Euler's functions. By Euler's formulas, I will write the value a naught. I know this is equal to 1 by L, 0 to, not 0, from alpha to alpha plus 2L fx dx. It's a case when there is no point of discontinuity, but in this case there is a point of discontinuity. So what I will do, I will split the integral in two parts, starting from alpha to the first point of discontinuity. Of course, in this case there is a single point of discontinuity, so I will split the integral in two parts, alpha to c, then c to alpha plus 2L. When x is varying from alpha to c, what is the value of the function fx? This is psi 1x. I will write here psi 1x dx, plus when it is varying from c to c, alpha plus 2L, this is our psi 2x dx. Fine. On the same lines, I can write the value of an. An is 1 by L. I can separate the integral in two parts, alpha to c, psi 1 of x into cos of n pi x by L dx, plus c to alpha plus 2L psi 2x cos of n pi x by L dx. And at the last, value of Bn, this is 1 by L, this is alpha to c, fx is psi x within this range, sine of n pi x by L dx, plus c to alpha plus 2L psi 2 of x sine of n pi x by L dx. Fine. Now I have written the case if the function is having one point of discontinuity. How we can split the integral if the function is having n points of discontinuity? See, if function is discontinuous at point, say, length of interval is alpha to alpha plus 2L, you may write it as a note. If there are n points of discontinuity, C1, then C2, then C3, then Cn, C3, then Cn, then in that case, we can separate the integral from alpha to C1, then C1 to C2, then C2 to C3, and so on. At the last, I will write Cn to alpha plus 2L. Once you have written the integrals, then we can find the values of a0, an and bn accordingly. Fine. So this is the way to write the Euler's formula for discontinuous functions. I hope the concept is clear. If it is clear, again I will ask you to like the video and subscribe the channel. Thank you.